So here again is the app that we're going to play with for this activity, and I'll use it in some problems in the homework and in class. And you can use the app on the screen here, or if you want it to be a little bigger, you can bump it into a new screen to play with. And we're going to play around with two set Venn diagram here. So the square above is my universe, and then I told the system to drop in two set Venn diagram. And click here to choose a name. And so I'm going to say, let's say that one's blue. And then this one, I'm going to make, how about circle? So then the way to use it, and I would do this in class with kids, they would have on their desk a piece of paper with two big circles on it, or we would get out some string and make two big circles and put some labels down, and they would have a set of these toys in front of them. And it's just getting kids used to, or getting organized, categorizing things. So anything that's blue, right, goes in the blue area. So I can just click and drag them in there. And you might be saying, well, wait a minute, you didn't do that right. And you are absolutely correct, because two of the shapes I put in here are also circles. So it's blue, so I can put it in the blue circle. It's a circle, so I could put it in the circle area, but I should really put it in the middle because that's the place where blues and circles go. So the two blue circles have to go here. The other blue shapes go outside of that region. And then we have circles over here. So then there are a bunch of other circles, and that yellow belongs here, not here, because it's not blue. So it just gives me a physical place to kind of think about categorizations, how things are related. And again, there's lots of research that show the more kids physically play with math, the better they do other kinds of math in the future. Now, the other shapes, they're just part of this universe, right? But they're not in this circle, or the blue set. And so I could just drag them and put them outside of here, but I'm going to skip that step for now. But they are technically part of this universe. So I'm just going to say, hey, my universe actually extends all the way down here to get this in there quicker. And so now I just want to talk about, again, the relationships between these a little bit more, like we did earlier with some set notation. Let's get a screenshot. All right, unfortunately, my toolbar came with it. That's okay. So we learned earlier a few things about set notation and the relationships between sets. So this crescent shape here, let's highlight you in blue. That is called the intersection of the two sets. So I have a set and I can count the elements in there. So I'm going to put an N to say I'm counting number. And I want blue intersect the circle set. And that's that blue highlighted region. Oops, highlighter, please. And I can see there's two things in there. Now, outside of that intersection, there's other blue things. So those are blue things that aren't circles, right? So this shape out here, let's make that one yellow with the highlighter. So I've got this other bigger crescent out here. And again, those are blue and they're not circles. So now I'm going to think about another set, the complement of the circle set. And there's a couple of ways to write complement. I like to write complement of a set, everything that's not in the set. If I could spell circle, here we go, by putting a bar over it. The book likes to write that by putting a little apostrophe, and some people like to put a little C there to go with it. I like that bar notation better. So that would be everything outside of the circle set. So I'm just going to do a little smaller drawing of that down here. So here's my blue set. Let's call that B. And here's my circle set, C. So if I wanted to illustrate in the picture everything that's not in the circle set, that would just be everything outside of the circle set. So I'm just going to circle around the circle set and then color all of that in. So everything out here outside of that circle is the complement of the circle set, everything out there. So if I want to talk about this yellow crescent I made out here, that set would be everything that's not in the circle set and everything that is in the blue set. So let's use, we can use blue. So if I just kind of highlight this right here, that's that set right there. So this funky crescent right here, that would be the blue set intersected with everything that's not a circle. And I like to put the bar over it, so the complement of the circle set. Sometimes people will write for that blue minus the circles. And we're not really doing a subtraction. We're not taking anything away, but it's kind of related to subtraction. I really don't like that notation, but you'll see it once in a while. But that side crescent here, again, that is the set of blue things, and they are not circles. So I can apply that same idea to the other side. This crescent, let's do this one in red. Get the red highlighter out. If my zoom would get out of the way. So this crescent over here, that would be the set of circles and not blue things. Would be that set right there. In the middle here, that's the actual intersection of blue and circle. Let's put that in here. So this set right here is blue intersect circle. So the interesting thing about two sets in a universe is the two sets split your universe into four corrals. So I'm just going to re-illustrate those down here into four distinct places. So I'm going to say place number one, that's the intersection. Place number two is one set, but outside of the intersection. Place number three is inside the other set, but not in the intersection. And then place number four is outside of the two of them. Right, so imagine, again, we have this corral, and in there we put two fenced in areas, and the fenced in areas happen to overlap. Then we've made 1, 2, 3, 4 different cages for stuff to live in. And then the labels for those cages, if I call this, say, these sets A and C, or I guess I was calling them B and C before. Region number 1 would be B intersects C. Region number 2 would be B intersect not C. Region number 3 would be C intersect not B. And region number 4 is everything outside the union. So one way I could write that is find the union of B or C and then take everything outside of that. So this would be outside of the union. Interesting things about that. The opposite of a union, the complement of a union, is an intersection. And so that's another weird idea I'll look at later with you. So, oops, wrong way. So what I'm saying is I looked at B union C, not all of that. And it turns out, we'll play around with this later, that that's the same as taking everything that's not B and looking at the intersection of that with everything that's not C. And the reason is a union and an intersection are complements of each other. And we'll look at that later. To be explored. All right.